All right, here's the video for the final review packet for unit test number 2. So let's just start going over the definitions. Instead of me writing them down, I have some things already pre-written on the page, so this video can hopefully go a little bit faster. The term reflection means a transformation that flips a shape over a line. So I've got maybe some line of reflection. This is the shape, and I flip it over that line. Now let's start looking at some of the rules that you might want to write down on your index card for it. So I've got this rule right over here. If I'm trying to do a reflection starting at point P, where it has coordinates x, y, and it's reflecting over the x-axis, little r for reflect, x-axis, the new coordinates are going to be, well, let's take a look over here. I've got my y-axis, my x-axis. If I start at this point right over here that I'm going to call the coordinates of it to be 3, 2, I reflect over the x-axis, well, I'll go 2 down and then 2 more down past it, and that'll bring me at 3, negative 2. So it looks like all I'm doing is if I start at x, y, after a reflection over the x-axis, I end up at x, negative y. Similarly, if I have my x and y axis, and this time I'm reflecting over the y-axis. If I start over here, let's say the point is 1, 3. Here's my y-axis. Well, I'm going to go 1 to the y-axis and then 1 past it, and this will end up at the point negative 1, 3. So I had x, y, and it became negative xy. Negative x, y is what I can use for reflecting over the y-axis. And we're going to need a little more space for this one. This is reflecting over the line y equals x. Let's pull out a blank sheet of paper so we can take a look at that one. And I can zoom out a little bit. All right. Here I have the point. I don't really like using xy as much. Let's use hk, because xy can get a little confusing. Though h is my x coordinate and k is my y coordinate. Let's say I've got, here's my coordinate grid, and I want to reflect over the line x equals y is what it said. And I want to find out, all right, what are the rules? What rule can I put down that's going to get me that? Well, first of all, the line xy is going to be something like 0, 0, x is equal to y. The point 1, 1, x is equal to y. The point negative 1, negative 1, 2, 2. I think you're getting it. So 0, 0, 1, 1, 2, 2, negative 1, negative 1. Here is what my line x equals y looks like. And if you recall, here, let's bring it to the point 1, 3. If you recall, the way I do this is I count down to the line or over to the line. So let me count down. I went 1, 2 down to the line, but because it's diagonal, instead of continuing down, I'm now going to go onto the other side of the line. So I'll go to the right now. 1, 2. I started at the point 1, 3, and here I ended up at the point 3, 1. So it looks like I take my x and y coordinates, which in this case are hk, and I switch them, and that gets me the reflection for x equals y. Reflection over the line x equals y. So if I start at some points, hk, and I reflect over the line x equals y, I'll end up at kh. Just like how I had 1, 3, I end up at 3, 1. And so I will leave that there for a moment. You can pause, and now we're going to move back to the sheet. So here, if I started at xy, I'm going to end up at yx. All right, let's keep moving on to the next definition. All right, a rotation is, and again, I'm just writing the quotes because I'm going to say instead of a transformation, I'll just, put quotes. It took a little less time to write that. A rotation is a transformation that spins a shape around a point. So I've got something, and I've got a point of rotation, and I'm spinning it around that point. This is rotating this compass. All right. We saw this rule before. Let's zoom in a previous video. If I've got the point XY and I rotate 90 degrees, I'm going to take my 2 points, switch them, and then make the new X coordinate negative. So if I was at XY, I'm going to switch it to become negative Y, X. Now next, that's the rule for that. Next, what about a rotation 180 degrees? Well, here I saw 90, I took them, flipped, and then changed the sign of my new X coordinate. So now I can think of it as saying, all right, well, I've got halfway there, rotating 90 degrees gets me to negative YX, and I have to do 90 more degrees. Well, I'm gonna flip them, and then my new X coordinate becomes negative. So this negative Y is just gonna get flipped over here. I keep that negative sign, and the X is just gonna make it up here, and I get a new negative sign in front of it. So it becomes negative X, negative Y from XY. And the next thing I'm gonna do is just the same thing again, right? 270 is my next rule I'm looking at, and that's just 90 more than 180. So I started at XY, flip switch, negative Y, X, flip and switch again, negative X, negative Y. I'm gonna rotate 90 degrees more. And so now I'm gonna, this is gonna get brought over there, and this is gonna get brought over here, and I'm gonna switch the sign for this one. So my negative X stays as negative X, and this negative Y becomes negative negative Y, which is the same thing as positive Y. And those are all of my rules for my rotations. Let's zoom back out now. All right. Let's keep moving on. A translation is a transformation that slides a shape around. And let's take a look at some sample problems with that. So here I've got my pre-image, what the rule I'm going to use for my translation is, and then the image that I'm going to end up with. So if my pre-image is the coordinates 4, 2, and I end up at 1, negative 4, well, I had to have translated from 4 to 1, that was minus 3 in the X, and from 2 to negative 4, that's going to be minus 6 in the Y, and I'll put a big T there for the name of my translation. Let's keep going on the rest of this. I start at negative 2, negative 7. I'm going to go positive 3 in the X, negative 1 in the Y. So negative 2 plus 3 gets me to positive 1. Negative 7 minus 1 gets me to negative 8. And now I'm just going to fill the rest of these in pretty quickly. I'll do one more talking. Now, here I start at something. I ended up at negative 5, 6. And that was after a translation of positive 4. Well, what did I need to start with that I add 4 to that I end up at negative 5? I can think of it as X plus 4 equals negative 5. And if I think about that and do the algebra, well, I'm going to end up with my original X coordinate was negative 9. Similarly, what did I start out with that I add 7 to and end up with positive 6? That's going to have to be negative 1. If you try the algebra out for that one, that would be X plus 7 equals 6. Well, my X value, or, well, actually, it'll be my Y value in this case. It will be negative 1 plus 7 gets me 6. I'm going to do the rest of these quickly and silently. Positive 3 minus 9, so it's going to be negative 6. Negative 4 plus 5 is going to be 1. Negative 6 to negative 4 is going to be a translation of positive 2. 8 to 2 is going to be minus 6. La la la. Started -3, so 8, 9, 10, 11 I started at, and -1 minus 6 gets me -7. All right, now let's keep going on to the next thing. The term rigid motion is a transformation that doesn't change shape or size. If I can do a transformation using rigid motions from one shape to another, it means that they are congruent. Rigid, by the way, means it doesn't bend. So this, even though I'm trying to bend this pen, it doesn't bend, so it is rigid. Something like a piece of paper is not rigid because if I bend it, it bends. Let's move on to the next page, and these questions I'm going to try and go through pretty quickly. I'm actually skipping these top 3 questions because you're not going to need to worry about those for your test. And let's move straight along then. Okay. The image of point -2, 3 under the translation T is 3, -1. What is the image of point 4, 2 under the same translation? So I started at, this is just like the questions that we saw over, here. This one gave me a start and an end. It wants to find the translation and then do that same translation onto a new shape. So I start at -2, 3. I end up at 3, 1. So -2 to 3 is going to be T of 5. 3 to -1 is then going to be -4. So now I'm just going to do this translation because I went from -2 to +3. So that's +5. 3 to -1, that's -4. I'm going to do that same translation to the points 4, 2, and that's going to get me 4 plus 5 is 9. 2 minus 4 is -2. Those are my ending coordinates. This is the answer to the question. All right. What is the image of point -3, 7 after a reflection in the x-axis? What is the image of point -3, 7 after a reflection in the x-axis? Well, I know that x and y-axis, if I was at -3, 7, I'm somewhere up here. The x-axis is going to bring me down here. My x-coordinate doesn't change. My y-coordinate, though, flips over that. It becomes negative, so I will be at the point -3, -7. All right, let's keep going. The image of point 3, 4 when reflected in the y-axis is what? Well, again, I've got my xy coordinate. Let's see, the point 3, 4 is somewhere over here. I'm reflecting over my y-axis, so the point's going to end up over here. My y-coordinate doesn't change, but my x becomes negative. I'll end up at -3, 4. If the point 2, -5 is reflected in the line y equals x, then what is the image? Well, we saw before, this is the line y equals x. I was at 2, -5, and we actually saw this rule earlier on in the page, and all I did with that was just to take my x and y and switch them. So I'm going to end up at -5, 2. Wait, -5, 2. Not that point. All right, I guess that one's it. So -5, 2. What are the coordinates of m prime, the image of m, after a counterclockwise rotation of 90 degrees? So m, I started at 2, 4. I'm doing a rotation of 90 degrees. Counterclockwise is positive. So that's going to get me to -4, 2, because that's my rule for rotations. What is the image of A, 5, 2 under a rotation of 90 degrees? Well, it's the same thing. If I start at 5, 2 and I rotate 90 degrees, I'm going to switch and change the sign of my new x. It becomes -2, 5. Let's keep going on these. What are the coordinates of the image -5, 2 after a clockwise rotation of 90 degrees about the origin? Well, a clockwise rotation of 90 degrees is the same thing as, so if I have this 90 degrees is going to be that way, I can go also counterclockwise 90, 180, and 270. Here, let me do that with, instead of my hands. I can either go clockwise 90 degrees, or I can go counterclockwise 90, 180, 270 to get me the same thing. And so I know that the rule we found earlier was just, if I have xy, it'll become y negative x. So it was that's for the rotation of 270 degrees, which is the same thing as a clockwise 90 degree rotation. So if I was at -2, 5, I will now end up at 5, 2. And if I want to think of that, I can do that as 3 90-degree rotations. -2, 5, flip and switch becomes -5, -2. Take that again, -5, -2. Flip and switch. So here I can write it out so we're not just trying to think about it all at once. If I start at -2, 5, I rotate 90. That gets me to -5, -2. 90 more gets me to 2, -5. 90 more to get me to 270 gets me to 5, 2, which is the answer that we came up with by just using the rule. And then finally, 180 degrees about the origin. This, it switches and switches, switches and switches. It just becomes changing the sign. So if I started at 2, -5, I end up at -2, 5. Let's keep going on here. What is the image of point A at 4, 2 after the composition of transformation is defined by this over here? The big thing to remember here is that you do the rightmost one first, followed by the next one. So if I reflect over the line y equals x, we saw that that is just, I flip my x and y. So if I start at 4, 2, I'll end up at 2, 4. And then I do a 90-degree rotation, which means I flip them again and I get negative in front. So I get -4, 2 as my answer over here. Let's keep going on to the next question. Find the coordinates of the image of 2, 4 under the transformation. I've got a translation followed by then a reflection over the y-axis. So I started at 2, 4. I translate +3, -5. So that gets me to 2 + 3 is 5. 4 - 5 is -1. And then I'm reflecting over the y-axis. Here's my y-axis. And here's the point 5, -1. I'm going to end up at this point over here because I reflected over the y-axis. So I'm going to end up at -5, -1. -5, -1. That is my full answer. Let's keep going. Write the single equivalent write a single translation that is equivalent to a translation of 3 and -1 and a translation then followed by -5, +5. So if I did first 3, -1, let's say from 0, 0, that would get me to 3, -1. And then I do the second one, that's that translation. I do this one then, -5, so that'll get me at -2, and this will get me to +4. This is the equivalent translation actually, because I just did, well, +3 - 5 is going to be -2. -1 + 5 is going to get me to +4. All right, let's go on to the last question here. The coordinates of triangle JRB are 1, -2, -3, 6, and 4, 5. What are the coordinates of the vertices of its image after the transformation? 2, -1, or sorry, first reflection over the y-axis, and then translation 2, -1. Well, reflection over the y-axis, if we do this guy, I've got someone at 1, -2, -3, 6, and 4, 5. Reflection over the y-axis means this guy goes here, this guy goes here, and this guy goes here. It looks like my x-coordinates are all changing to become the opposite of what they started out with. So I'm going to end up at -1, -2, 3, 6, and -4, 5. And then I translate 2 to the right, so, and then 1 down. This will get me to, and I'll write them in a row this way. 2 to the right from -1 gets me to +1. 1 down from -2 gets me to -3. He's done. 2 to the right, 1 down. Then is going to get me 5, 5. He's done. And then 2, 4. And these are all of my coordinates after that series of transformations. Whew! All right, final page, and then we are finished with all the review packets. Let's zoom out a little bit and finish up here. On the accompanying grid, graph and label AB, line segment AB, where A is 0, 5 and B is 2, 0. So 0, 1, 2, 3, 4, 5 is that point right there, A, and B is at 2, 1, 2, 0, B. Under the transformation, first a reflection over the y-axis, then a reflection over the x-axis. Don't forget the right first when I have this circle thing. So first this maps onto A prime prime, and then B maps onto B prime prime. Graph and label both of these. All right, so I'm just going to graph and label A prime prime, B prime prime, and then after that we'll take a look at the second part. So first I'm reflecting over the y-axis. A prime is over here again. B prime ends up over here because this is my y-axis, so I went 1, 2 to the left, so I'm going to go 2 more to the left. Reflect then over the x-axis. A prime is now going to move. It was 5 above, so I'm going to go 5 below. 1, 2, 3, 4. 1, 2, 3, 4, 5. This right here is A prime prime. B prime prime doesn't move. So here was AB, and here is A prime prime, B prime prime. Now, because it's a line, you might think, so actually this is the final thing for the first part. Next it asks what single transformation would map AB onto A prime prime, B prime prime. Maybe I could do just a translation down, but I want to be totally right in terms of I want B to end up on B and A to end up on A. If I take this and I rotate it around, I do believe that I'm going to get that correct thing. So let's see. If A was at 5, 0, 5, and B was at 2, 0, if I rotate 180 degrees about the origin point, well, that would end up at 0, -5, because all I do for rotating 180 degrees is change the signs. And this would bring me to -2, 0, which is exactly what I have for, this is A and B, this is A prime prime and B prime prime, except I did it in just one transformation, which was rotating 180 degrees. Whew. All right, let's keep going. On the accompanying grid, graph and label triangle ABC with vertices labeled there. So I'm going to go to 1, 2, 3, 1. That is A, B is at 0, 4, 1, 2, 3, 4, B. And C is at 1, 2, 3, 4, 5, negative 5, 1, 2, 3, negative 5, 3. This is just regular C. So here's my triangle that they gave me. Oh, A is going to get cut off. That's okay though. All right, there's my triangle. On the same grid, graph and label A prime, B prime, C prime after the transformation reflection over the line y equals x, and then a reflection over the x-axis. So here's my line. I'll draw that one in purple. Here's my line y equals x. I'm going to go, all right, let's see, 2 up and then 2 to the left to get A prime. And now, hold on, let's take a look. This was at the point 1, 2, 3, 3, 1, and ends up at 1, 3. So hold on, let's just use that rule again, right? If I started at 3, 1, 0, 4, and negative 5, 3, all I'm doing is just changing the coordinates each time. So A prime is going to be at 1, 3. B prime is going to end up at 4, 0. And C prime is going to end up at 3, negative 5. That's much easier writing it all down instead of having to draw it all. It's going to get really messy there. All right, now I'm reflecting over the x-axis. So that one is done. Now I'm going to reflect over x-axis. Well, again, here's my x-axis. If I'm going to reflect this guy over it, I'm just going to 3 down, and I'll keep going 1, 2, 3 down. This is at 1, 3. It's going to be at 1, negative 3. Just my y-coordinate changes when I reflect over the x-axis. So this becomes A prime prime at 1, negative 3. This will be B prime prime at, 4, 0. Doesn't change at all. And this will become C prime prime at 3, 5. I changed that y-coordinate. So here are my coordinates, and let's plot and label these. So I've got it at, I'll do in purple the A prime, B prime, C prime. So then 1, 2, 3, 4, 0. This is B prime, and C prime ended up at 1, 2, 3, 1, 2, 3, 4, 5. This was A prime, B prime, C prime after the reflection. That looks pretty good. I took it and I flipped over that line there. And now I'm going to reflect over the x-axis, which I will do then in green ink. So this ends up at 1, negative 3 right there. B prime stays at the same place. This, by the way, is A prime prime. And then C is going to end up at 3, 1, 2, 3, 4, 5. C prime prime. And here's my final image of the shape, and that looks pretty good because I reflected it over here, or it's like this, reflects over that line over there. And this is kind of what all looks like drawn out. All right, final question for this review packet, if anyone's watching. Whew. The coordinates of the vertices A, B, C are here. Draw and label them here. Graph and state the coordinates after reflection over that line. Then after reflection over the x-axis. And then after a translation. Whew. All right. This is already a 30-minute video. I think if you've watched all this, you're pretty comfortable doing these things. Try to practice it yourself, and good luck on that test. Have a good night.